So let's begin with the odd number of electrons. And the odd number of electrons, there's no better example than NO, or nitric oxide, or nitrogen monoxide. Okay. And this is, by the way, a very, very important molecule in your body. It's a signaling molecule. We'll tell you about it. N has 5 valence, and O has 6. So what's the total? 11. There's no charge, nothing. So isn't this odd? Odd number of valence electrons. Okay. Anytime you have odd, you will know that you will violate the octet rule. Just keep that in mind. So let's begin. We draw N attached to O. Put them on oxygen because it's more electronegative. And then we put the rest on N. Okay. So far I have 8 plus 3 plus 1. That's 11. Okay. N is not happy, clearly. Only has 2, 4, 5. Needs how many? Needs 8. So therefore, we need to do a double bond. So let's do a double bond. Take one of these lone pairs and make them a double bond. Okay, I'm going to stop using colors really because... Okay. Let's count now. How many do we have? Well, we have now 2, 4, 6, 7. Still not enough. Now, be very careful what you do next, because sometimes some people, including me when I was in undergrad, I thought about, but then I discovered the mistake is, let me use one of these to make a triple bond. Okay. Good. Let's look now. Oxygen is happy. It still has 8. 2, 4, 6, 8. But let's look at nitrogen. 2, 4, 6, 8, 9. Okay. 9 valence is bigger than 8. That's not acceptable. That's forbidden for N equals 2. For N equals 2, second row, second period, that's not allowed whatsoever. So the correct structure is right here. Okay, so this one is incorrect because it has 9. So yes, it has 7. It has less than the octet. So what is this now? What is this called? So anytime you have an odd number, you will form something, and you heard of this before. I'm going to use a different color. This is called, anytime you have, notice how you have an unpaired single electron. Unpaired single electron. Anytime you have a species with an unpaired single electron, we have a name for this. We call it a free radical. Free radicals are what cause aging in the body, oxidative stress with the peroxide. But nitric acid is actually a good free radical because here it is. Nitric oxide is right here. It's released, and what it does is that it signals for smooth muscle, causes something called vasodilation. Vasodilation. And what it does is that it increases the blood flow to the body. Of course, you can't, your body can't just release NO indefinitely. That's going to cause all kinds of stress, especially indefinitely. So what happens is, essentially, after whatever the process is in the body, mechanism, the metabolism, your body actually shuts it down by releasing what we call an inhibitor. So you have an inhibitor right here. It's the PDE dash 5. Okay, so this is called, right here, this is called an inhibitor. Okay. I don't know if you can read down here what is this. So what happens here is that, well, by accident, people were working on this drug right here, Viagra, and they were using it for hypertension to lower the blood pressure. But they discovered that through trials that it does something else. What it does is that it blocks those inhibitors right here. It blocks them. And it still allows the nitric oxide to flow to the nerve ending. And it does it at, it's obviously the mechanism is much more involved. It does it as certain, brain activity where, it causes the blood to flow to one organ in the body. So there you go. Interesting. Let's go now. Finally, second one, I'm sorry, not finally, one more after that, is less than an octet. And what I need you to pay attention is, this is rare, but occurs with Be and B. Also, I want to add and Al, aluminum. Okay. Why? Let's look at BH3 or even BF3. Doesn't matter. Let's start with BH3. B has 3 valence. Right here, 3 valence. H has 1 each. So that's 6. Okay, right away you see it's less than 8. So there's no way for B to get 8. So you attach them like this. And you get, that's it. You used all 6. 2, 4, 6. So if you notice here, B has less than 8. Now, anytime you have less than 8, okay, we have a name for this. You're going to study it in Gen Chem 2. We call this a Lewis acid. Because what it needs is, it has less than an octet, and it needs something to give it the octet, and that's where the reaction comes in, okay? Okay, so you might say, well, what about BF3? Okay, B, F, F, and F. So 3, 7, 7, 7. Okay, 7 times 3 is 21, plus 3 is 24. Okay, B, F, F, F. Put the dots. Okay, that's 24. Okay, well, here it is. Still has less than an 8. But you're saying, well, we have lone pairs. Why can't we do a double bond? So that's why the formal charges is important. So we'll go with that. We'll make a double bond here. You see how everything tied in this class. There's no room really for disconnecting what you learned from previous lectures, even in stoichiometry from this. Everything is related. So let's look. Oh, B is happy. But if you do the formal charges, 7 valence, sorry for fluorine has 7 valence minus, let's count. We have 1, 2, 3, 4, 4 electrons in the lone pairs, and then 2 bonds. So that's 7 minus 6, essentially here. You have 6 is plus 1. Okay, that's a big problem. And if you do B, you'll get a -1. The reason why is because F, okay, F is the most electronegative atom. You can't give it a positive. Pushes everything out of the way and it gets the most of the electrons. So in this case, this is unacceptable. So that's why it's still deficient. So valence formal charges are critical. All right, so let's continue. So you can't have a double bond. I'm going to give you as a rule of thumb, and take this when you get to organic chemistry, is halogens do not form double bonds. Halogens do not form double bonds, so they stay single bond.